Welcome to the AI innovation space. We are your experts, and I'm Iyanu.
And I'm Todd.
We're here to offer our unique insights and hold conversations with top leading innovators in the world of AI and machine learning.
We dissect and discuss the often complex realm of AI in an accessible way and go deep in discussing the innovative technologies that impact our lives every day.
This podcast is sponsored by Lumen, an IT contractor offering a creative and human-centric approach to medical imaging, cybersecurity solutions, training and support, and more. Illumin's values of ingenuity and connection make us a leader in adopting innovative technologies for federal healthcare and beyond.
Visit Illumin's website at www.illumin.com for an overview of the services offered and to read our blog series on leveraging AI for your business. Thank you so much for listening, and let's begin.
Hello, and welcome to another edition of the AI Innovation Space. I have here with me my co-host, Todd. Todd, how you doing?
Very well, thanks, Jan. Looking forward to today's episode.
Yeah, same. And we have our guest today, Himanshu. Hi, Himanshu, how are you doing?
Hi everyone, I'm doing good. Uh, Thank you for inviting me to your podcast and looking forward to it.
Excellent. So, Himanshu, I see that you have a role currently in Maddox. Some of the discussions we're going to be having today is around visual quality control, some of the Kaggle competitions you've been, into. And I'm 100% sure myself and Todd are very, very interested in your work in automated assessments of tumors in the breast. And we're so looking forward to having this conversation. But before we get started, I think, a good way to basically kick us off is by having you do a little bit of introduction about yourself, how you got into AI ML, and then we can dive into the topics for today.
Yeah, sure. So, my name is Himanshu. I am a final year undergraduate student at NIT Raipur. I am pursuing my Bachelor's of Technology in Computer Science and Engineering. And then, like for me, I got introduced to programming and computer science in my first year. And then, like about 2 years or so, I was mostly into web development or you can say full stack development. And then later, where I got to know about machine learning and the artificial intelligence, and then I know like it kind of resonated with me more than what I was looking into web development. So, yep, I think that's more. I started participating in Kaggle competitions. I started looking into more blogs out there. I mean, for me, it was just looking out what I can do with this programming. Then I found out that if you see from the impact wise, then machine learning in general has a wider impact than what I was doing or exploring at that time. That was web development.
That's really, really awesome, And so how did you basically make that shift into machine learning? Why machine learning? Why not just software development?
Yeah, I mean, I don't know the exact moment at which I got interested, but if I'm not wrong, there was what I can say. I was just scrolling through the YouTube, watching some free code camp tutorial on full stack, and then I got this recommendation from Andrew Ng's classical, well-known course on machine learning, and for me, it was the first time I had heard about it. So I just what I can say, go through that playlist, and then the nice thing about that particular playlist is that there are a lot of approaches to get started into machine learning or artificial intelligence, and then few of the people focus more on the mathematics behind it, and then they start teaching it. And then if you see the fast AI's course or the Andrew Ng's course, they do not like the math is not that heavily involved. Like you can later study the linear algebra, the multivariable calculus, statistics, probability, but for a beginner, it's a very what I can say friendly way to get to know to machine learning. If you see the what I can say tutorials by Andrew Ng or the Jeremy Harvard, the founder of the Fast AI courses.
I see. Thank you. So, Amanshu, what are you looking to do kind of long term with your career? Are you trying to focus on machine learning, or is there a particular aspect of
Yep.
the
So
area that really interests you? Can you share about that?
yeah, I mean, the key learning till now has been it's very difficult to decide what you really want to do. So my what I can say, like if I have to pick up one thing, that will be is artificial intelligence in general when mixed with or mingled with other branches, like if you see biomedical imaging or drug discovery, or currently the hype is of the large language models, then you see a significant improvement in the reach out from the previous algorithms which were there. Like a lot of stuff was being done in biomedical imaging, or there were some chat bots too, but the recent breakthrough with the help of deep learning has just skyrocketed those firms. So my learning has been you learn the fundamentals of machine learning or deep learning, and then throughout your journey you try to get a hang of its interaction with various other branches. Sometimes you might like some biomedical imaging stuff, sometimes it might be what I can say geospatial images and so on. So I am hoping to do a master's after some time and then explore more areas in which deep learning can help or make a larger impact in it.
So you mentioned you're interested in, biomedical images and machine learning. I think you have some experience in that.
Yeah, if you start with Kaggle and you watch some what I can say tutorials, the most of the times the data set is always curated for you. Like you always have this train, test, and validation split, and you just have the most of your time goes into reading other scripts or just applying a traditional or what already is there. What I can say a standard architecture of that particular, let's say, deep learning algorithm, and you just apply to it and then you fine tune it just to get the highest score. But the moment when you enter some industry or some lab from the academia, then you have to what I can say delve a significant amount of your time into that particular domain before you get just started. So for me, I was lucky enough to do an internship in inference, which has a lot of expertise in electrocardiograms and then biomedical imaging, and there I got to know about the interaction of the computer vision. And as already mentioned, there I did that automated assessment of the what I can say breast cancers.
Awesome. So I wanted to ask you a question. When you talk about visual quality control, what does that really mean? And how does that tie to what you do at Maddox AI?
Like the visual quality control, as the name suggests, is the quality control from the vision perspective. Generally, it's done by human. That if you have some expertise into that particular domain, you can differentiate between, let's say, there is some automobile industry or some manufacturing industry, and then you have to produce a lot of parts, and then depending upon your customers, you have some tolerance limit, and then while you are producing though or while you are manufacturing those products, you want to be into that tolerance limit which your customer has provided, so that you can give that particular customer a good product. So generally that checking of the tolerance or the checking of the quality is mostly done by humans. But with the recent startups like Maddox AI, we are trying to apply deep learning and computer vision so that we can automate it. So in a way, it will be multiplying the effectiveness of that particular quality inspector, which already there is. So the deep learning model, let's say there are what I can say, a gauge or a screw which the manufacturing company produces, and then when you automate it, the deep learning model will pinpoint or predict masks which are not according to that model good, and then instead of going through the entire product, the visual inspector can look into those particular areas which are specified by the model. So in a way, we are boosting his or her performance.
I see. I see. So is there a way that that kind of task would help the quality of annotations?
Yep, you can say so. Like it will be what I can say a feedback kind of. So I mean, you can't directly say it will help because sometimes it might be wrong. Like the predictions might
Mm-hmm.
be wrong, but
Mm-hmm.
when you give it as a feedback, then the person there, then for him or her, it will be very easy to just say
You
whether
just
it's good
say,
or not, and
yeah, yeah,
yeah,
yeah,
and
got
then you just what with this loop you can improve significantly the performance of the model.
it, got it, got it, got it. Also, can you discuss some of the various cargo competitions that you have participated in, and the ones
Yep,
that you won? Because it appears you won some cargo competitions, correct?
yep, yep. So, like in my beginning stages, I was what I can say looking more into Kaggle competitions, and I was what I can say applying to various internships parallelly. And then in the meantime, like I did not got what I can say any internship. So the only way to learn and increase my knowledge in the deep learning was to participate more in Kaggle competition so that you can read someone else method. And because generally you see like the winners post their write-ups and then they post their writing solutions on a GitHub or some Kaggle discussion, so you go through it. So the I have got some good positions, but I have only won one medal. That was the bronze medal, and then it was a question answering. Like the competition name was Chai. It means tea in Hindi, and then the task was like there will be a sentence, like context will be given, and then there will be a question from that context, and then you need to provide answers using that construct, using that question. So let's say the context is something like there is a girl named Alice. She goes to, let's say, XYZ school. And then the question might be, where does Alice go to school? And then the answer will be the name of that school. So it's a question answering kind of mechanism. And then where I use, if I'm not wrong, I use that XLM Roberta. And then we did the assembling of various 2 to 3 models. And then we were able to get a good or a significant position there.
So, what kind of Kaggle competitions do you look for to participate in? Is there anything that
Like,
recommendations you might
yep. So generally,
they
I
were
will say,
participating?
so like if someone is getting what I can say, just started in the Kaggle competition, then depending upon in which data type you want to explore, so you might be into natural language processing, or you might be into tabular data or some image data. Then depending upon the data in which you want to explore into, you should choose that particular competition. So let's say you are into mostly into tabular data, then Kaggle hosts monthly competition like tabular playground series. It's abbreviated as TPS. Then you can participate in those. And I'm not sure, like there is no what I can say prize involved, but there are some what I can say Kaggle merch kind of thing. So it's a very good way to get just started into that tabular data, and then like learn not only about learning the models or how others are writing the what I can say the overall flow of their models. There is another benefit in the Kaggle is that you get to know or you get to network with other machine learning enthusiasts where with whom you can team up with for other competitions, or you can learn more about like the general community at the Kaggle is very friendly, and then you can just ping them on, I guess, on LinkedIn or Twitter that hey, hi, I am in this and that year, I'm looking into this competition, how should I proceed, or what do you think, how did you got into the particular internship, or how did you got a job at that particular firms, and then they really will help or guide you. So you should consider Kaggle as a very good platform to discuss things, to learn how others are implementing their scripts, how others are what I can say deciding what models to use or not, and then there is another benefit of networking.
I see. Thank you for sharing. One other topic we're interested in talking about is I know you worked on an automated assessment of breast tumors, and we saw your PowerPoint
Yeah.
presentation on that. Can you kind of talk our audience through kind of that presentation a bit and what you guys were trying to accomplish and how you were using
Yeah.
machine learning?
So the overall, uh, you have to understand the what I can say, the balancing of the research and the product making in the industry. So the like in the ideal case, the problem was to make some automatic assessment of all types of cancer. But if you want to develop a product, you will divide a problem into sub problems, and then you will try to solve that particular small problems and see if it's feasible for you as a small startup to solve it or not. And then if you see that you were able to solve it, then you will just scale it up. So we identified breast cancer, and then we thought like we must break into it. And then once we are able to build a pipeline for this breast cancer, then we can do it for like the pancreatic cancer and so on. So we had like two types of data. One was the in-house data set, and there are few other competitions related to breast cancer. One of them was Tiger Grand Challenge. So there is a website, grandchallenge.org, something like that. And then they regularly host what I can say data intensive uh, biomedical what I can say competition. So if someone is already participating in Kaggle, then they can also participate on that particular platform. Then we collected data from those particular competitions, and then there is also a TGCA, which is a widely known and open source data set. And like the inference is a both hardware and a software company, so we also make robotic arms to digitalize and scan the pathological images or the tissue sections which they cut, and then there's a mechanical arm which takes those glass slides and feed it to what I can say microscope which has a camera at its one end, and then you just capture it, and then whosoever your customer is, you can provide them with the data. So the task was of the assessment of the breast cancer. So just to delve into like if you have the what I can say, a normal pathological tissue section, then there will be normal region or the normal tissue region, which you need to first segment out from the glass slide. So that's what I can say, one of the segmentation tasks at the beginning. So once you do that tissue segmentation, then there are two steps. You want to segment the tumor region inside it. But the problem lies within the fact that these whole slide images are very big. Like they are something like uh, 2 gigabytes or 3 gigabytes. So these whole slide images, they are a pyramid. So depending upon your magnification, let's say you want to see that particular image at 1x, then you will only see a small resolution picture. And then if you want to see something at 10x or 20x or 40x, you will zoom in, and then you will only see those particular base tiles. So it's more of a like a Google Maps. So like in the Google Maps, if you zoom in, then you can see a lot of relevant information at the highest magnification. But if you zoom out, then you will not see a lot of information, and then the image gets smaller. So the next step is to get the base tiles within that tumor region and then feed it to the model. And then the model will, on those particular base tiles, will predict the mask for whether it's a tumor or not. And then you need to stitch it back. By stitching it back, I mean like to concatenate all those predicted masks. And once you concat all those predicted masks, you will see a region where the tumor is. And then depending upon various other tasks, like you want to count the tumor infiltrating lymphocytes or other particular types of lymphocytes, or you want to do some qualitative or quantitative assessment, then, depending upon those tasks, you might develop a segmentation model or an object detection model at a 10x or 40x.
Excellent. Thanks for sharing. Also, I wanted to, get into the tool you built on annotation, image data annotation. Is it supposed to be a tool on top of Label IMG? I've used Label IMG a lot, but is it supposed to be a tool on top of Label IMG? I know
No,
Label
it's not.
IMG does annotation, but it doesn't do as much of segmentation. But can you explain what you're doing there?
Yep. So, like before joining Maddox, I got an internship at Karlsruhe Institute of Technology. So where there was this PhD whom I contacted on LinkedIn, and I got an opportunity to work with him. So they had developed a KaIDA, the name of that labeling tool. It's an open source labeling tool, and they had developed the KaIDA image labeling tool, which provided labeling for semantic segmentation and the instance segmentation. So the instance segmentation is you count the countables, like you might have an image and you want to count like there is cat 1, cat 2, cat 3, cat 4. So you want to really count the instances. But in the instance segmentation, you are not interested in the count of those instances, but the semantic meaning, like here lies the cat, here lies the dog, here is the sky, and so on. But a recent trend has been, because a lot of development in the, what I can say, in the deep learning models for computer vision, the demand has been shifted from instant segmentation and semantic segmentation to a combination of both the segmentation, that is panoptic segmentation, where you do both of these stuff. So they wanted to develop various algorithms which will help their annotating tool to provide the annotation for the panoptic segmentation. As I explained, it already had instant segmentation and the semantic segmentation labeling assistant, and then I wrote the, what I can say, code for allowing the panoptic segmentation. And one more interesting thing about this kind of tool is like the unlike other image labeling tool, you get a lot of features, like you can, depending upon, like you can run a ResNet model or some other LXNet, or you can, there's a drop down, you can choose it, and then you will get pre-assisted annotation. So you get the image, you pass through a model, and then depending upon that model, you will get some pre-assisted, what I can say, annotation. So if you like them, you can edit them and so on.
That's good. That's good. Thanks for sharing that. Todd, you're going to say something?
Yeah. So what are some applications that you think that image data annotation tool would be very beneficial for?
So, there's a very good saying, like the data is the new oil. But the fundamental problem lies, like with the recent trend in the increasing capability of processing, storage, and availability of internet to a population which were earlier not able to access due to, what I can say, economic or financial condition. But recently we have seen that there is a significant jump in the amount of data being generated. So it's very good to have data, but what's more better is you want to get the information out of it. And by information, I mean like you want to label it, you want to annotate it so that it's more organized and you can do a lot of more stuff. So within the image, like the image domain, you might have a lot of, what I can say, image data, but only self-supervised learning methods like the SSL methods will work. And what we have generally seen, those are not that good. And generally, the supervised learning methods work. So the demand has been to get a lot of data along with those annotations. So with the help of these tools, you can annotate it. But the question comes, this annotation is very cruelsome, like it takes a lot of time, and then we have seen in a lot of cases that the person doing the annotations was not paid or compensated accordingly. So the next task has been to, what I can say, add another branch which will be in a, what I can say, loop which will predict some mask, and then the human annotating it will edit it, and then you will get a feedback, and then you will keep on improving the predictions. And we are hoping that it will increase the, what I can say, time which earlier was being invested into the annotations.
I see. All right. Thank you. One other question I have for you, I'm kind of interested in your thoughts around how data that you find in Kaggle competitions that you participated in kind of differ from real world data like you're working with now at Maddox
Oh,
AI. Could you kind of expand on, how do the data
they
sets kind of
are
differ?
they are completely like you just can't compare them. Like in the Kaggle, um, it's what I can say. It's just pre-processed. Like I can just start with like how the data generally one which receives at various firms is. So most of the times there can be what I can say misunderstanding in the communication, or some of the times they will say that the data is there, but when you go into that particular table and you look into it, then you will see that most of the times it's not there. And the other problem is the noise. Like, so let's say you want to a particular, like you are taking a data from a manufacturing company, and then you want to see the timestamps or some other annotations, and then it's being done by human. And then what we have seen is like human will prefer some kind of what again, they will take some shortcut or will do something, so you can't really trust out in that. And then you will see there's a lot of noise coming in. And then once you do this kind of join over all these tables, depending upon whether you are using some relational database or a non-relational database, a lot of times a lot of what I can say values will be missing, and then you will be thinking upon how to impute those. Like what I've seen in the Kaggle, like most of the rows are already filled, and then in some of the cases there are nan values, but it won't matter because those are so few that you can just drop them. But here you really have to think about the best imputation technique, and then you have to what I can say communicate a lot regarding. So I mean I like one of the other example might be, so like at the Maddox, like I don't know that much German, so most of the column names and most of the description is in German. And then another problem is like some of the times it's like there are a lot of German words like you with a double dot on it, and then in English when you translate it, like when you are doing some kind of an LP thing, then you will see it gets translated into something else. Like I guess it's something like UE. And then in German, numbers are like the commas are replaced with dots. So generally, what in the United States or India, like if let's say you have 3,499, you will see a comma after three. But in the German numbers, it will be 3.499. So I guess like there is a lot of noise, and then you have to communicate a lot, and then you have to really invest a lot of time into thinking about the imputation techniques which you will be later diving into.
I see. Thanks for sharing. So one thing I'm kind of interested as well is kind of your take on, more general, like AI being used right now in various applications. Are there any applications where you kind of feel like AI or machine learning are kind of underutilized, or you think be beneficial to see more research or effort towards?
I was really expecting that you might ask that. It's being overutilized. Like generally, what I have seen is people will directly adapt a very complicated model instead of going with a linear regression or a logistic regression or a PCA. But what I have seen is like in few of the firms at where I work, like not every company is big, and then you don't have a large amount of annotated data. And then you see the most of the tasks in the image section particularly belongs to supervised methods. So for them, it's very difficult to get that accuracy with that amount of small data. And what we have seen that there are very few, what I can say, breakthroughs in the self-supervised domain. Like recent only, like Meta released two methods. Like one was the segment anything model, and after that they released the Dino version 2. But except except that like I have worked with Dino version 1, and what my experience was like, if you don't have and like such huge data, it generally does not work. But yeah, it was good to see that there has been some progress in self-supervised learning, because I think it will be the way to go. Because if you've seen like the recent large language models, the advantage is you don't really need annotations for the normal training. You only will need while fine tuning it, because you have that masking technique in which you take a large text corpus and then you have to predict the next word which is already there. I mean, that's one of the reason we have the, what you can say, it sounds very realistic that whenever we see some response from a generative pre-trained model like Chat GPT or so.
Mm-hmm. Okay, thank
So
you.
I get, yeah.
Do you have any or where you assume or where you see, machine learning going in the next 5-10 years as we start wrapping up?
I mean, mine observation is like there are a lot of, what I can say, growing branches or observations which I like. These are just of my thoughts, which I generally see people tweeting. Like few of the people are from the thinking that in a very near time we will see that the prediction by these models will be as far as with the humans. Like generally Elon Musk and few others. But if you see Jan LeCun, the director of the AI at the Meta, he does not think so. There are a lot of opinions regarding it, and then there are a few people. Like there recently was I don't know who initiated it. I'm forgetting his name right now, but there was some demand like you should pause the training for large language models for about 6 months or so. So, like my personal take will be like the best way to control or bring ethics into machine learning will be always to lead it. Like you cannot control everyone what they are doing with the data or what they are doing with the latest architecture which they are developing. So the best way is to make your own contribution and make it, what I can say, like a open source kind of thing, like stable diffusion or so, that most of your work is open source so that everyone can see and criticize it. And to me personally, I don't think like something like banning something or stopping the training for something will, I mean, it's not possible to do it, so it's better not to talk about it.
I see. Thank you. Just one final question I have for you is there any insights or challenges that you faced or anything that you feel would be useful for someone trying to get their foot in the door on machine learning? Is there anything that you feel is good insights to share for someone starting out?
Yep, mine insights will be like it's always better to, what I can say, follow a structured kind of, what I can say, teaching methodology. Like like it will be always better if you follow like you have like, I mean, there are two ways. You can just start googling, you just start reading blogs, you start implementing it. But the better way, if there is already a great professor who has a great playlist in a very structured way, then it's better to follow it thoroughly. Like there is a website, deep learning drizzle, something like that, and there you can find a lot of playlist. And then like to name some, I can start with like for computer vision there is CS231N. And then you see like they start from the very beginning, they have very advanced mathematics later on, and then you name like object detection models, self-supervised ways, segmentation models, they have everything. And for the natural language processing, you have that CS234. And so for my personal intake will be like, in the beginning what I was not knowing about a lot of curated playlist or a structured way of diving more into deep learning. So mine advice will be to follow these playlist or a structured way of methodology, go through over them twice and thrice, make some notes, participate into Kaggles. And then one of the other, what I have seen is like people don't do that much, but they should also network. Like people should also invest in networking, and they should try to talk with other people who are doing similar stuff. So let's say you are into medical image or visual quality inspection using computer vision, then you should on Twitter or LinkedIn reach out to those people who are doing that particular thing which you are looking into. You can reach out to professors, that if you can get an opportunity to work under their supervision or guidance and so on.
This was a great conversation with you, Himanshu, and thank you so much for coming and sharing your insights and thoughts. Really looking forward to. Thank you so much for coming on the podcast.
Yeah, we really appreciate you joining us today.
Yeah.
Yep, thank you too
Himanshu
for
Maurya.
inviting me, and for me it was also very pleasant to talk with you and share whatever I could.
Excellent. So thank you all so much for joining another edition of the AI Innovation Space. We're glad you're able to stop by and listen to what it is that we shared today. And just look out for more of our podcast, and talk to you all soon.
This has been the AI Innovation Space, sponsored by Illumin. Thanks so much for listening.
Be sure to connect with us through LinkedIn and the Illumin website to learn more about how AI and emerging technology can help you. Also, be on the lookout for our next episode coming soon. Thank you so much for joining us. Have a wonderful day.